Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Zamri and my number metric is DE210053. Alright, so for today I will explain about an introduction about this project. Alright, so I highlight 5 point. Alright, so first thing first is the heart of the system lies in the seamless integration of the LPC 1768 microcontroller and the LM35 temperature sensor. Alright, so this means that this microcontroller and this temperature sensor is a play a big role in this project to uh to to process the conversion of analog temperature signals into manageable data. Alright, and then the second one, the secondly, is the microcontroller takes charge of the heater and cooler, dynamically adjusting the operation based on real-time temperature readings. So this means that this ensure that the water temperature is consistently maintained within the specified optimal range of 55 to 80 degrees Celsius. Right, so this mean it have a safety. That mean when the water is below that degree, if the heater on, and then when the water is uh higher than 80 degree, cooler on. So that it have a safety. We put a LED to know that the water is hot or cool. Alright, and then the thirdly is the microcontroller plays a dual role. So this means that the microcontroller, it takes a data at uh at the LM35 temperature sensor. So then it sent to the PC, and that's what means that the microcontroller plays a dual role. And then the ultimate goal is to create a stable and controlled environment within the manufacturing plant. So this means that this project is create a stable within the the water. It become 55 to 80 degrees, not below, not and it have a when below the cooler heater on, when the higher the cooler on. So this means the water become in the range of 55 to 80 degrees, and then continuous monitoring and control, so that it can still continuous and monitoring this project in the PC. We can see the data. Right, so that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Hafiz bin Sulaiman, DE210044. Okay, I will continue for the flowchart, which is the flowchart is to use a LM35, which is the temperature sensor in a manufacturing plant with the LPC1768 microcontroller as the main controller. It will maintain the water temperature within a desired range of 55 degrees to 80 degrees. Okay, this is for the flowchart. Flowchart will be starting with a start in order to start the system. Okay, after that it will go to the LPC1768. It will take the value from LM35, which is the temperature sensor. After that, for the temperature data, it will send the temperature to the computer communication port, which is COM. Okay, after that, it will go to the control driver, which is LPC1768 will control the driver. The driver will control two two parts, which is cooler and the heater. When the temperature is below 55 degree, the driver will make the heater to turn on. Okay, if no, the driver will make the heater off. The option number 2 is when the temperature is higher than 80 degree, the driver will turn off the cooler. The driver will turn on the cooler. If not, the driver will still make the cooler turn off. Okay. After that, it will be a loop and continue to looping from the start. Okay. So for the question, which is from the challenging task, consider to improve the safety of the system where the system will immediately shut down upon emergency situation. So for the task, we make a ISR1, which is it will be the cut off. In other way, is for the kill switch to turn off all the system. Okay, ISR1 will turn off the heater and cooler and display the reading on serial port. After that, it will return. Okay, that's all for me today. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zamani Amni bin Muhammad Zani. Nama matric DE210048 and I am from group 6. Today I want to explain about our group assignment about coding in KVL Vision. Okay, today figure 1 shows block diagram of temperature control system. We use LPC1768 microcontroller, and our desired water temperature is within the range from 55 Celsius to 18 Celsius. Okay. First coding is we take the include coding is LPC17 that we use the microcontroller of LPC17XX. This coding will provide include function for prototype that we use microcontroller LPC17XX. In this assignment, we use microcontroller 17C8. Okay. We will use the coding void wait as initial T, void team initial void PWM init void GP I0 init void initial void ADC init void UART initial void and void EINT3 RRQ handler void. Next, we take a look at the this coding initial main void. We use the unsigned initial result equal to 0. The different part of this coding is it will be used as a temperature control system that we will figure by the main function called necessary initialization procedure. We will configure timers enabling PWM. This one for cooler and heater control. We initializing GPI 0 pins, configuring interrupt for a start button. This interrupt, configuring the analog to digital converter ADC to sensor readings, and initializing UART for communication as a example. Then the code will wait for a start signal from the user as by clearing the GPI 0 pins connected to the heater and cooler and monitoring button press. Okay, this is the start of our code to read ADC analog digital converter to on the heater and off the cooler. If voltage equal or less than 0.55 or in this our assignment the range for the water temperature is 55, and if the voltage is less than 55, the heater will be on and the cooler will be off. The duty cycle for the situation is 10% to 30 seconds, and the brightness of LED will be low. The next coding is send data to PC, result top, result and 0. The extract first from 8 bit, and the result white is result and 0 multiply 0 f00 equal to or larger than 8, larger than 8. Extract next 4 bit. And the next coding is the delay function called wait as stops the running of a program for a given moment of time, measured in microsecond. This is a red time counter, and this is to enable timer counter. It made use of LPC17C8 microcontroller timers 3. By setting the bit 1 of the TCR timer control register, it will be reset the timer counter. Next is set TCR bit 02, enable the timer counter. After that, the method goes into loop where it keep checking to see if the timer counter is smaller than the given delay. In essence, it waits until the allotted amount of time has elapsed before permitting the program to continue. For this one, the timer 3 initialize via team init function by setting the CTCR counter timer control register to 0. You set up the timer to run in timer mode. Next is set the matching bit in the power control to for peripheral register PC, O and P to activate timer 3. Okay, for the next coding is void PWM initial void. We will use LPC pinecon pin cell for 1 less than 0, PWM 1.1 pin, P2.0 pin function. For following that, it active PWM1 output by setting 9 bit in the PWM1 control register PCR. The prescaler PR is then set to 24, resulting in the PWM cycle with 1 microsecond resolution. When the PWM counter mesh the value in mesh register 0 MR0 and the timer counter TC, the mesh control register MCR is set to trigger event. This one. Okay, by setting MRO to 1000, the PWM cycle duration is set to 10 milliseconds. Furthermore, it will be the duty cycle for PWM 1.1 is set to 10%, 0%, indicating that PWM output will be begin with no pulse. Okay. Next, and the coding is in this section. The code initialize 3 crucial components for a microcontroller based system. First, this GPI0 initialization configure that the pin 0.16 and pin 0.17 as output pins to drive and external drivers such as cooler and heater. But for pin P1.30, it will be point as a start button. The initial init function activate a falling edge interrupt on GPI 0 port 0. This one, that is the code we read to a falling voltage on one of the pins on that port. Okay, ADC. Finally, the ADC initial function will be enables the microcontroller to read analog voltage, as we know that the one who initialize the power on the ADC. And the next one is for the last coding is external interrupt 3. The EINT3 RQH handler function is an external interrupt 3 interrupt service routine. That's all for me. Thank you.
Hello, my name is Brian Jordan Wilfred, and my matrix number is CE2100335. And today I will be showing the result analysis from our code over here for the assignment 2. My friend has already explained about the code before, So I will explain about the result. So first thing first, we will need to do is to build the target files. Click here and then make sure that there is no errors and then also the warning. And next we will click this icon for start and stop debug session. Just click OK. And then there is this peripheral which is for the GPIO 0, 1, 2, which is equivalent to the port 0, 1, and 2. And also over here is the AD converter. So behind this is the logic analyzer. The first parameter is for the S2 out, which is the transfer rate. And then also at the bottom over here is the LED. So we know that the assignment 2 has been given us the temperature range, which is 55 degrees until 80 degrees. So the port 0, which is GPIO 0 here, we will be using the stop button at pin 0, the heater on pin 17 over here, so 16, 17, this is the heater, and then cooler pin 16 over here, which is this one. And then port 1 or GPIO 1, we will use the start button at pin 30, so 31, and then over here the back is 30. And lastly, port 2, which is also GPIO 2, over here we will use the LED at pin 0. So for the AD converter, we can use the AIN0 to make an input for the temperature range. So let me demo this. So first thing first, what we need to do is to run this code, which is to start code execution. And then let we put the inputs in the AD converter. So when the temperature range is below than 55, we know that the heater will turn on. So let's see. Below than 55, for example, 53. Okay, so then we will click the start button. You can see over here, pin 17 turn on, which is the heater. You can see that the heater will increase the temperature from 53 into more than 53 to keep this range. Okay, so after that we will see the transfer rate. So from 2, 11 to 11. And then this is the LED LED duty cycle, which is approximately 1 millisecond difference, and then the stop time is 9 milliseconds. So next, we know that when the heater turn on, the temperature will increase. So what we will do is we will see the output and the temperature range is between 55 and 80. So for example, 70. So we will click the start button. As you can see over here, both the cooler and heater turn off because it is the temperature range that we want. We will see the duty cycle and the transfer rates when both of the heater and cooler is turned off, which is over here. Stop this first. So the transfer rate is 26.3, 26.3. The LED duty cycle is approximately 5 milliseconds and the downtime is also 5 milliseconds. And when the temperature exceeds 80 degrees, we'll see what happens. More than 80 is, for example, 90. Click the start button. We'll see that the cooler will turn on, which is on pin 16, and then the heater turn off, which is on pin 17. Okay, so next we will see the transfer rate and also the duty cycle. The transfer rate also change from 4 and then 1D. And then the LED duty cycle also change, which is uh, approximately 9 milliseconds. Then the stop time is approximately 1. So when we want to stop this device, we can just press the stop button, which is at the port 0, pin 0. So when I click this, You can see that uh, the device is stopped, the data transfer stopped, and also the LED will turn off. So that is all for the result. Thank you very much.
Hello, my name is Usam Absam Mohammed. I would like to present a conclusion for our assignment 2, microprocess microcontrol conclusion. In conclusion, it can be stated that all of the objectives we are met while completing this project, compiling and deploying in the coding was successfully after study the working principles temperature such as the microcontroller used and the software used to run the project. Despite some unavoidable circumstances, was gained a lot of experience and benefits of because of the LBC 1768 board has many features that enable various multi project deployment days. We can explore a lot of things, particular components selecting. Furthermore, it enable us to use it to quickly grasp all of the inside tricks here we meant to create a genius multi project for the industrial. In summary, students will able to integrate the coding for the hardware or later on during our assignment we actually learn about software okay by using monitoring this temperature and how it actually can work when the temperature is becoming low, when high, when middle. So if we need to do a hardware, so we can actually program it as a hardware. So we can produce a hardware by using this coding. So actually, that's we can up our project, our assignment. Thank you very much.